Welcome Tomcats, welcome Buckeyes to another episode of Mr. B Teaches a Class of No One. Thanks for tuning in. By now you should have completed the do now that we did at the beginning of class. I'll go over the answers. The first question asked you to plot the following points and then connect them to make a polygon. That polygon's name is ABCD. So I'm going to start by plotting point A at -2, 4. Label it with an A. Point B, -2, 2. That's point B. Point C is 3, 4. And point D is 3, 2. I'll label that with the letter D. Now I'm going to connect my vertices here. And it looks like I have a polygon, A, B, C, D. Now it asks me to use the following words to fill in these blanks. Quadrilateral ABCD can best be described as a rectangle. But it could also be a parallelogram. Or a quadrilateral. I do know that it's not two things. I know that it is not a trapezoid. And I know that it's not a square. And I know that because the definitions of both those polygons don't allow this to be those shapes. Question number 3. Which number is represented by this point here? Now, I know it's in between 1 and 2, so I can get rid of D and I can get rid of A. I know that 1 and 5/10 would be right here, and A is on the right side of that. So I know that that is point C, 1 and 75/100ths. Now I'd like you to flip the page. Take 1 minute to do today's skill builder. We're going over adding decimals and dividing. All right, that's 1 minute. You're tracking me up front. You have nowhere else to track. The first one, Jason bought a drink for $2. A hot dog for $1.70. And 1 piece of gum for 75 cents. Now, I want to know how much he paid in total, so I'm going to add. Before I start adding, I'm going to move my decimal straight down here. So I add 0 plus 5 to give me 5, 0 plus 7 to give me 14, and I carry the 1. 1 plus 2 is 3, plus 1 is 4, for a total of $4.45. Now the second question was asking me to divide 6,300 divided by 20. First thing I do is I look at if 20 will go into 6. It does not. 20 will go into 63. 20, 40, 63 times. I multiply 3 times 20 to get 60. and I subtract. 63 minus 60 gives me 3, and I bring down my 0. Now 20 will go into 30, go in one time. 1 times 20 is 20, and I subtract. 0 minus 0 is 0, 3 minus 2 is 1 for 10, and I bring down my 0 for 100. Now 20 will go into 100, 20, 40, 60, 80, 100, and even 5 times. 5 times 20 is 100, and I subtract. And when all of my numbers down here are 0, I know that I'm done. I don't have a remainder, and I don't have a decimal. So 6,300 divided by 20 gives me an answer of 315. Go ahead and flip the page. Today's aim, we're going to be reflecting points in the coordinate plane. Reflecting, when you hear the word reflect, think of mirror. You're going to be mirroring a point on the coordinate plane. So, a reflection is a transformation that creates a mirror image of a shape. In the coordinate plane, there are 2 mirrors. The x-axis and the y-axis. Now, if we reflected the point 2, 3 across the y-axis, where would it be? Well, the first thing you're going to do is I'm going to plot my point 2, 3 on my coordinate plane. I'm going to move to the right 2 and jump 1, 2, 3. And I'm just going to label that A. Now, if I wanted to mirror this, reflect this across the y-axis, first thing I'm going to do is find the y-axis. That's this one running up and down. And I know that I need to find its mirror, which is going to be on the exact opposite side of y. So I'm going to move over 1, 2, and then go up 1, 2, 3. And if I look at my graph here, or my coordinate plane, I can see that A1 is the mirror image of A. And this is at point minus 2, 3. Now, when we're going through this, see if you can notice a pattern here. Now, what if we wanted to reflect this across the x-axis? Remember, the x-axis is the one that runs horizontally from left to right. Now, if this is the mirror, it's going to end up somewhere on the opposite side. So I know that it'll still be at 2, but instead of jumping up 3, I need to jump down 1, 2, 3. And at this point, I'm going to put A with 2 hash marks. That just tells me that this is the second reflection of my first point A. And this point is located at 2, negative 3. Did you start to notice a pattern yet? Because what I'm seeing right now are a couple changes in my negative numbers. Remember that this is the y-coordinate and this is the y-coordinate. This here, the x-coordinate, followed by the y-coordinate. Now, there are 3 pretty simple steps for reflecting points on a coordinate plane. The first step is to identify which axis is the mirror. Which axis I'm going to be reflecting that point over. Now, my second step is if the point is reflected across the x-axis, the y-coordinate takes the opposite sign. So if it were positive, it would change to a negative. If it were negative, it would change to a positive. And the x-coordinate would stay the same. Now it's just the opposite for if the point is reflected across the y-axis. If the point is reflected across the y-axis, it's the x-coordinate that takes the opposite sign, and the y-coordinate stays the same. Now I know this might seem a little confusing, but stick with me. I promise we'll go over some examples here in just a minute. Go ahead and flip the page. Now just a reminder, if you think I'm going too fast, feel free to pause it or rewind it if you would like to hear something over again. So for my guided practice, number one is asking me to plot point A, or find point A, which is plotted at -3, 6 on the coordinate plane here. Now, I'm being asked to reflect point A across the x-axis. Remember, the x-axis is the one that runs horizontally, and then label it with A with a little hash mark. So, I'm going to find my x-axis, find my A coordinate, and find its opposite. Now I know if A is at positive, or is at -3, 6, I'm going to go -3 and then go down 1, 2, 3, 4, 5, 6. And this is my point A dash. And now I'm being asked to write my new coordinates. So I run before I jump. So I'm going to run backwards 1, 2, 3, -3. And I'm going to jump down 1, 2, 3, 4, 5, 6. I'm going to jump down -6. Now part B is asking me to reflect this point across the other axis, the y-axis, and label it with A hash hash. So I'm going to find my point A and reflect it to the other side of the y-axis. I know that I'm at -3 here, so I'm going to find +3 and then move up 1, 2, 3, 4, 5, 6. And I'm going to label this point A dash dash, just like this. Now, part B is asking me to write the new coordinates of this point. I see that I went 1, 2, 3 because I run first. 1, 2, 3, then jumped 1, 2, 3, 4, 5, 6. So I ran 3 and jumped 6 for a new coordinate of 3, 6. Now I'm wondering if in a complete sentence what the difference was between reflecting over the x-axis and reflecting over the y-axis. Now I'll give you about 30 seconds to get a start on this. The difference between reflecting over the x-axis and reflecting over the y-axis. Go ahead. If you're still writing, go ahead and finish. When we reflect over the x-axis, the y coordinate changes its sign. Flip the page for one last guided practice problem. Now this one is going to be done without the use of a coordinate plane. So if you can help it, don't go back to the previous page and look at the coordinate plane. See if you can do this in your head by noticing that pattern. So I know that I have a point at 4, 3, and I want to reflect that over the x-axis. Now, if it's reflecting over the x-axis, I'm going to find my x coordinate, which is 4. Remember, it goes x, y. I'm going to underline my x coordinate so I know that that doesn't change. Now I'm going to change my y coordinates sign for a 4, negative 3. Now, explain in a complete sentence the rule for how the coordinates of any point change when it is reflected across the x-axis, Now I know that when any point is reflected across the y, or across the x-axis, the y coordinate changes its sign. And I know you're starting that sentence with a capital letter and finishing it off with some sort of punctuation. If you're really excited about this, you can make it an exclamation point. Now, if we were to reflect this point over the y-axis instead, what would my new coordinates be? Well, I started with 4, 3, and I want to reflect it over the y-axis. So I'm going to underline my y coordinate to know that that is not going to change. And now I can change the sign to my x coordinate to negative 4, 3. And that's it. When you hear reflecting, think mirror. When you see x-axis as a reflection point, underline that x coordinate and change the other sign. Now you've got the rest of the time to work on your independent practice. Remember, independent meaning I want you to do it by yourself. That way I know how far along you are. Take the rest of the time to work on that.